In this video, we'll be discussing further on the topic impulse and momentum. And now we'll move into Newton's law in terms of momentum. Now we know Newton's first states that an object will remain at rest until an unbalanced force acts on it, and Newton's second states that when an unbalanced force acts on an object, it will cause an acceleration which is directly proportional to the force and inversely proportional to the mass. Now, Newton's first and Newton's second use the equation F net is equals to ma, and if we go back to the definition of acceleration, which is just the change in velocity divided by the change in time, we can do some manipulation and we find out that actually the equation can be rewritten as the net force is equivalent to the change in momentum divided by the change in time. Now, from this, we can draw that given that time is kept constant, the change in momentum is always proportional to the net force on an object. The equation now gives us a new definition for Newton's second law, which is now we can define it as that the net force is equivalent to the rate of change of momentum. Keynotes on the relationship between change in momentum and net force is that whenever net force is zero, then we are not going to have any change in momentum. This means that when there's no force, there's no change in momentum that is going to be possible.